on Comptia Network Plus, managing network documentation. Creating network documentation is one of my least favourite tasks in network administration. It just isn't as exciting to me as learning about the coolest new technology or tackling and solving a challenging problem. But as part of it, maybe that I figure I know my network well enough. After all, I installed and configured them. So if something comes up, it should be easy to figure out and fix, right? And most of the time I can do that. But as networks get bigger and more complex, it gets harder and harder to remember it all. Plus, it's an integral part of the service I provide for my clients to have seriously solid documentation in hand to refer to after I've left the scene and turned their network over to them. So while I'll admit that creating documentation isn't something I get excited about, I know from experience that having it around is critical when problems come up for myself and for my clients, technicians and administrators who may not have been part of the installation process and simply aren't familiar with the system. Using SNMP in Chapter 6, Introduction to the Internet Protocol, I introduced you to Simple Network Management Protocol, SNMP, which is used to gather information from and send settings to devices that are SNMP compatible, making sure to thoroughly review the difference between versions 1, 2 and 3 that we discussed here. Remember, I told you SNMP gathers data by polling the devices on the network from a management station at fixed or random intervals, requiring them to disclose certain information. This is a big factor that really helps to simplify the process of gathering information about your entire internetwork. SNMP uses UDP to transfer messages back and forth between the management system and the agents running on the managed devices. Inside the UDP packets, called datagrams, are commands from the management system to the agent. These commands can be used either to get information from the device about its state, SNMP GET request, or to make a change in the device's configuration, SET request. If a GET request command has sent, the device will respond to with an SNMP response. If there's a piece of information that's particularly interesting to an administrator about the device, the administrator can get something called a trap on the device, so no whining. Like it or not, we're going to create some solid documentation because I'm guessing that you really don't want to redo it. It's a very good idea to keep it safe in at least 3 forms. An electronic copy you can easily modify after configuration changes. A hard copy in a binder of some sort stored in an easily accessible location. A copy on an external drive to keep in a really safe place, even off-site. In some case something happens to the other two, or the building or part of it burns to the ground. So why the hard copy? Well, what if the computer storing the electronic copy totally crashes and burns at exactly the same time a major crisis develops? A good thing you have the paper documentation on hand for reference. Plus, sometimes you'll be troubleshooting on the run, maybe literally, as in running down the hall to the disaster origin. Having that binder containing key configuration information on board could save you a lot of time and trouble, and it's also handy for making notes to yourself as you troubleshoot. Also, depending on the size of the intranet and the amount of people staffing the IT department, it might be smart to have several hard copies. Just always make sure they're only checked out by staff who are cleared to have them, and that they're all returned to a secure location at the end of each shift. You definitely don't want that information in the wrong hands. Now that I've hopefully convinced you that you absolutely must have tight documentation. Let's take a look into the different types you need on hand so you can learn how to assemble them. I'll cover schematics and diagrams next and discuss baselines and policies, procedure, regulations later when I cover network monitoring. Schematics and diagrams. Reading network documentation doesn't exactly compete with racing with your friends or on jet skis, but it's really not that bad. It's better than eating canned spinach, or sometimes it's actually interesting to check out schematics and diagrams, especially when they describe innovative, elegant designs, or when you're hunting down clues needed to solve an intricate problem with an elusive solution. I can tell you how many times, if something isn't working between point A and point B, a solid diagram on the network that precisely describes exactly what exists between point A and point B has totally saved the day. Other times these tools come in handy is when you need to extend your network and you want a clear picture to know how to expand, how the expanded version will look and work. Will the new addition cause one part of the network to become bogged down while another remains underutilized? You get the idea. Diagrams can be made, sketches created while brainstorming or troubleshooting on the fly. They can also be highly detailed, refined illustrations created with some of the snappy software packages around today, like Microsoft Visio, SmartDraw, and a host of computer-aided design CAD programs. Some of the more complex varieties, especially CAD programs, are super pricey, but whatever tool you use to draw pictures about your networks, they basically fall into these categories: wiring diagrams, schematics, physical network diagrams, logical network diagrams, asset management, IT utilization, vendor documentation, wiring schematics. Wireless is definitely the wave of the future, but for now, even the most extensive wireless networks have a wired backbone that rely on to connect them to the rest of humanity. The skeleton is made up of cabled physical media like coax, fibre, and twisted pair. Surprisingly, it is the latter, specifically unshielded twisted pair UTP, that screams to be pictured in the diagram. You'll see why in a minute. To help you follow me, let's review what we learned in Chapter 3, Networking, Topologies, Connectors and Wiring Standards. We'll start by checking out figure 20.1, a diagram that pictures the fact that UTP cables use an RJ45 connector. RJ stands for registered jack. What we see here is that pin 1 is on the left and pin 8 is on the right. So clearly within your UTP cable you need to make sure the right wires get to the right pins. No worries if you've got your cables pre-made from the store, but making them yourself not only saves you a bunch of money, it allows you to customize cable lengths, which is really important. Table 20.1 matches the colors for the wire associated with each pin based on the Electronics Industry Association and Telecommunications Industry Association Alliance EIA TIA 568B wiring standard. Standard drop cables or patch cables have the pins in the same order on both connectors. If you're connecting a computer to another computer directly, you should already know that you need a crossover cable that has one connector with flipped wires, specifically pins 1 and 3, and pins 2 and 6 get twisted to ensure that the send port from one computer's NIC network interface card gets attached to the receive port on the other computer's NIC. Crossover cables were also used to connect older routers, switches and hubs through their uplink ports. Figure 20.2 shows you what this looks like. This is where having a diagram is golden. Let's say you're troubleshooting a network and discover connectivity problems between two hosts. Because you've got the map, you know the cable running between them is brand new and custom made. This should tell you to go directly to that new cable because it's likely it was poorly made and is therefore causing the snag. Another reason it's so important to diagram all things wiring is that all wires have to plug into something somewhere, and it's really good to know what and where that is, whether it's into a hub, a switch, a router, a workstation or the wall. You positively need to know the who, what, where and when and how of the way the wiring is attached. For medium to large networks, devices like switches and routers are rack mounted and would look something like the switch in figure 20.3. Knowing someone's or something's name is important because it helps us differentiate between people and things, especially when communicating with each other. If you want people to be specific, you can't just say you know that router in the rack. This is why coming up with a good naming system for all devices living in your racks will be invaluable for ensuring that your wires don't get crossed. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.